Hey AQR students, we are doing SAS Student Activity Sheet 2 today. And in this we are introducing the idea of Fermi questions. So the specific Fermi question you're going to answer today is how many tennis balls will it take to fill up the room you're in? Okay, at school we're going to be using the classroom, but since you're not in the classroom, you'll just do whatever room you are in watching this. This is the room you will choose to fill up with tennis balls. All right, so we're going to take you through the process. We'll talk about what a Fermi question is, and I'll talk a little bit about your upcoming project starting tomorrow, which will be doing a Fermi question presentation. Okay, all right, here we go. Okay, so we're looking at SAS 2, filling your classroom with tennis balls. Clearly, you guys are not in a classroom, so this is going to be a little different from you. But whatever room you are in your house, I assume you're in your house, just imagine that you're going to fill that room with tennis balls. All right, so we're going to do kind of three estimates here. Your first estimate, I want you to write these down because I'm going to have you turn them in. Your first estimate, I just want you to eyeball it, take 5 seconds. How many tennis balls? Okay? Write it down right now. Done. Okay. Second estimate, I want you to take a minute, 2 minutes, and eyeball a little closer. Okay, think about the size of a tennis ball. Think about how high the ceilings are, how long the walls are, and try to find a better estimate of the number of tennis balls needed. Number of tennis balls needed to fill whatever room you're in. Okay, pause the video, get your estimate. Okay, third estimate. Now for this one, it's going to be handy. What you really need to do is you need to go out and find yourself either a tape measure would be great, or if not, a ruler or a yardstick or something like that. And I want you to actually measure the room you're in, get measurements on that. And then maybe if you have a tennis ball handy, you can measure that if you want, or you can just go online and find how big a tennis ball is, and from those numbers see if you can get an estimate for the number of tennis balls. And you're going to take several minutes to do this, maybe 5, maybe 10 minutes, maybe even more. All right, so pause the video, make your measurements, measure your room, measure a tennis ball, or get the information off the internet, and then one last time get a third estimate. Okay, and hopefully this will be the best estimate. All right, so pause the video, do that. Okay, so you have found the estimates, and we're going to do this in class tomorrow, but it's going to be, classroom's probably pretty much bigger than whatever room you're in. We're going to do the same sort of thing in class tomorrow. Well, I'm speaking on Sunday night, so actually it'd be today for you on Monday. But I want you to now, answer number 3 here. Number 3 says, in determining your estimate, what mathematical model of a tennis ball did you use? Did you measure it yourself? Did you go online and get something? What model of the room you're in did you use? And again, hopefully you made measurements here. You got something fairly accurate. Did you make other simplifications or assumptions? For example, did you assume that there was no furniture in the room you're in? Did you think of it as just like an empty room that you're going to pour tennis balls in from the top? Or did you have some other idea in mind? Okay? So I'm going to ask you to share those. I'm going to ask you to share your estimates. I'm going to ask you to share your assumptions on today's practice when you turn this in. So this is an example of what we call a Fermi question. Fermi was a mathematician at the University of Chicago back in the early part of the 20th century, and he became famous for coming up with these Fermi questions. All right, and talks about it on the back here. Fermi question, how large is the crowd, is an example of a Fermi question which requires estimating physical quantities to produce an answer. Enrico Fermi was an Italian physicist known for his ability to take limited information and arrive at a reasonable numerical estimate. He approached a problem by setting a lower estimate, a value that the item in question was more than, and an upper estimate, a value that the item in question was smaller than. Fermi then worked through the problem using this approach and reached a numerical estimate within identified limits. Fermi worked at the University of Chicago, and his classic question was, how many piano tuners are there in the city of Chicago? Fermi questions rely on making logical assumptions about a situation to reach an estimate to an order of magnitude, usually a power of 10. That is, the estimate is expressed in hundreds, thousands, millions, and so on, whatever unit is appropriate for the question. Another example of a Fermi question is, can every person in the world fit inside a cubic mile? So what assumptions do you need to make? What information do you need to find? All right, so think about that. What assumptions are we going to make to answer this question? Can every person in the world fit inside a cubic mile? And then what information do we need? Okay? So for the next couple of days, I'm going to assign each of you a Fermi question, and you're going to make a presentation, a PowerPoint or Google slide presentation. And since the class is going to be presenting these in class, since you're not in class, I think that you can record yourselves on the slide presentation, so that would be the way you're going to go about doing this. All right, so tomorrow on Tuesday, you will be assigned a Fermi question. You'll have a couple days to work on this, to do some research, but I want you to go about it without, some Fermi questions, there's a lot of very popular ones, and some of the ones I use are ones that you can actually find answers to online. But I want you to, I don't mind if you do, after you're through with it, checking to see if it's available online and comparing your answer with what they got. And it could be that you have as good an answer, if not better an answer, than what you can find online. But I want you to do this, on your own without going online and just copying somebody else's answer. All right? So you'll be given some kind of Fermi question. And again, a Fermi question it's an estimation. There's not going to be any exact answer. There's usually no way of getting an exact answer. Okay? So look forward to that. All right? And think about this today, and we will see you tomorrow.